the next lecture is on Six Sigma maintenance. Okay. So Six Sigma is a quality control program. Okay, quality control program. It is developed by Motorola. So for improving their quality, total quality of their parts. Okay, so it improves the quality of the output of a process by identifying and removing the causes of defects and focuses on reducing the variation in a production process. Okay, so here they are identifying and removing the causes of defects and focuses on reducing the variation in the production process. So the basic unit of assessing the quality of any product is defect. Okay, the basic unit of assessing the quality of any product is the defect. So the defect is an unacceptable state of a product which arises out of the process that produced in which causes extra work, reject and increased cost. So by reducing the defects and variation, a firm can have higher or tighter control over its operations and increase their cost effectiveness and can enhance the productivity. So Six Sigma is using to enhancing the productivity of the firms by having tighter control over its operations and increasing their cost effectiveness. So Six Sigma refers to a measure of process variation that translates into an error or defect rate of 3.4 parts per million. Okay, a very low rate of 3.4 parts per million defect rate, which means 99.99966% of all opportunities to produce some feature of a part are statistically expected to be free of defects. Okay, so out of 1 million parts, 99.99966% of the parts must be satisfied without any defects. Okay, so to achieve quality performance of Six Sigma, special set of quality improvement methodologies like DMAIC, which will be explained later, and the tools are required. So these methods and tools are thought to be a small group of workmen. Okay, very small group of workmen known as Six Sigma champions or black belts. Six Sigma champions or black belts who are assigned for the responsibility of process quality. So the responsibility of the total process quality is heading on the Six Sigma champions or black belts. So these black belts drives a cross-functional team, also known as Six Sigma green belts, where members from various departments are present to achieve quality performance of Six Sigma. Okay, so hence the goal of Six Sigma is to have a production process with no errors and to also to trace out any errors occurring in the production process, thereby minimizing the variation in the product. Okay, the goal of Six Sigma is to minimizing the variation in the product by taking no errors and also to trace out any errors occurring in the production process. So here we have Six Sigma champions or black belts, and under them we have Six Sigma green belts. Okay, so Six Sigma maintenance methodology and process. So Six Sigma methodology improves any existing business process by constantly reviewing and returning the process. And it uses a methodology known as DMAIC to achieve this. Okay, DMAIC. And D for define, M for measure, A for analyze, I for improve, and C for control. Define, measure, analyze, improve, and control. Okay, so let's see each one. So first one is define. So after a Six Sigma project is selected, the first step is to clearly define the problem. So the problem must be described in measurable terms that facilitate further analysis. Okay, for example, a firm might have a history of poor reliability of electric generator it manufactures, resulting in a Six Sigma project to improve generator reliability. Okay, if the company manufactures electric generator and it is very weak in its reliability, so we are implementing Six Sigma procedures to improve the reliability. And how to do it? Let's see. A preliminary investigation of warranty and field service repair data might suggest that the source of most problems are brush wear and more specifically brush hardness variability. So here we are doing not much of work by simply investigating the warranty and field service, repairing data. Okay, the basic data. And here we have found out that the reasons for the problems are brush wear and more specifically brush hardness variability. So the problem is defined as reduce the variability of brush hardness. So by simply reducing the variability of brush hardness, we are expecting to increase the. So a good problem definition statement also should identify CTQ. CTQ means critical to quality characteristics that have the most impact on product and service performance. Also describe the current level of performance or the nature of errors or customer complaints. All these are some problem definition statements. Okay, and benchmark best performance standards, determining the availability and reliability requirements, calculate the cost or revenue implications of the project, and quantify the expected level of performance from a successful Six Sigma project. So all these statements are just good problem definition statements. Okay, so here we are using all these two just for defining the problem. So the defense phase should also address such project management issues as what will need to be done by whom and when. Okay, the basic project management issues like what will to be done by whom and when. So next is M for measure. So we have defined the problem and some basic informations we have. Next, measuring. So during this stage the team determines or measures the current performance of the process. Okay, the team determines or measures the current performance of the process. During this phase data is collected from different sources. Okay, measuring means just some data collection from a lot of sources we have. So data from existing production process and practices often provide important information, as does feedback from supervisors, workers, customers, and field service employees, etc. Okay, so it is just some data collection from the working field. Okay, so next is analyzing. So we have defined the problem, we have measured by some data collection, and next we are analyzing the data. So the analyze phase of DMAC focuses on why defects, errors, or excessive variation occurs. Okay, so we are analyzing the data. So the data collected is analyzed to find the true possible root causes, for bad quality, and identify areas that needs to be improvement. Identify the areas that need to be improved in order to reduce the defects. So we have to reduce the defects. For that we have to identify or analyzing the reasons. So steps involved are check and verify collected data. Okay, checking the collected data and verified, draw conclusions from the data, verify conclusions, determine scope for improvement, and find the root cause. Okay, if we find the root cause we can eliminate the errors. Okay, so next is improving. I for improve. So once the root cause of a problem is understood, the analyst or team needs to generate ideas for removing or resolving the problem and improve the performance characteristics. So now we have known the reasons for the problems. Okay, so next we have to avoid these reasons and we can improve the productivity. So here we are doing that in improve. So this idea gathering phase is a highly creative activity. So most people have a natural fear of proposing a silly idea. Okay, however such silly ideas may actually form the basis of a creative and useful solution. Okay, maybe the idea be a silly one or a hard one, but such ideas can actually form the basis of a creative and useful solution. Okay, so effective problem solver must learn to develop the ability to generate a large number of ideas at this stage of the process, whether practical or not. Okay, so the problem solving person must have a large pool of or a large number of ideas. Okay, so he has to select the better one, whether it is a practical or. So after the set of ideas have been proposed, it is necessary to evaluate them and select the most promising one. Okay, select the most promising idea among the idea pool. Okay, this process includes confirming that the proposed solution will positively impact the key process output variables. So the problem solution often entail technical or organizational changes. So let's see. So often some sort of a decision model is used to assess possible solutions against important criteria such as cost, time, resources required, and barriers to implementation such as resistance to change or organizational culture. Okay, so if the proposed idea may be take some changes or organize on the organizational culture during the implementation, whether it does such things. So often some sort of decision model is used to assess possible solutions, okay, against such important criteria as we mentioned above. So care should be taken while we are implementing these procedures. So to implement a solution effectively, responsibility must be assigned to a person or a group, which will follow through on what must be done, where it will be done, and when it will be done, and how it will be done. Okay, so all the responsibility must be assigned to a single person or a small group. Okay, so care should be taken while implementing the idea. So last one is C for control. So in this phase, steps are taken to ensure that the process do not drift away from the newly improved standard. Okay, so we have implemented the newly improved idea or standard. So here in the C or control, steps are taken to ensure that the process do not drift away from the newly improved standard. So in control phase, the team will create a monitoring plan to measure the success of the implemented plan and develops a response plan if there is a dip in performance. Okay, so if the dip in performance by implementing the new plan during some phase, so we have a monitoring plan to measure the implemented plan. Okay, and there is a response plan to respond to the monitoring plan. Okay, so controls might be as simple as using checklists or periodic status reviews to ensure that the proper procedures are following. Okay, it also includes training of the workforce and instituting controls to make sure that improvements do not die over time. Okay, so during the control, it also includes training of the workforce and instituting controls to make sure that improvements do not die over time. Okay, the improvements do not die over time. That's under control phase. And the features of Six Sigma are: it helps to eliminate waste, okay, and improve the efficiency of maintenance work. It follows a structured methodology known as DMAIC. It is a data-driven methodology and requires accurate data collection. Okay, it requires accurate data collection. Otherwise, failures may occur. So, for the process being analyzed, Six Sigma approach is used for improving process, lowering defect, reducing variability, reducing cost, increasing customer satisfaction, and increasing profits.